Okay, this video is for your Exponents and Scientific Notation Study Guide. You're going to follow along with the video. Make sure that you're writing down the answers as you go. If you have any questions that don't get answered during the video, please make sure you ask me, and that way I can help you in case you don't understand. So all you have to do is really just listen, pay attention, and follow along. So we're going to start first with the I can apply properties of integer exponents. So number 1 says 16 to the 10th plus 16 to the 4th. When we're multiplying, we will add those. So I'm going to have 10 plus 4, which is 16 to the 14th. Okay, and then I have division, g to the 19th over g to the 12th, which is subtraction. So 19 minus 12 is 7. Okay, when you have a power to a power, you're going to multiply. So 20 to the 7th times 5 would be 20 to the 35th power. Make sure you're making your powers as well, not whole numbers next to it. Okay, we have a little bit of both here. So a power to a power, we would multiply. So we have n to the 18th power. Then we have multiplication, which is addition. So your final answer would be n to the 18th power. Division is subtraction. 22 minus 9 is 13. So now I have 8 to the 13th times 8 to the 11th, which is addition. So your final should be 8 to the 24th. I have addition first. So 17 to the 14th over 17 to the 5th, which ends up being 17 to the 9th power. Okay, the next one is I can apply properties of integer exponents. So leave answers as a value or variable raised to a positive exponent. So when you have a negative exponent, remember you need to make it into a fraction. So this would be 1 over b to the 8th. A power to a power is multiply. So I have 3 to the negative 25. Since it's negative, I need to turn it into a fraction. So it would be 1 over 3 to the 25th. Adding negative 12 plus 2 is negative 10. So I would then have 1 over 10 to the 10th power. Number 10, add first. So I have 7 to the 9th power over 7 to the 15th. That's subtraction, which is 7 to the negative 6, which then turns into 1 over 7 to the 6th power. Division is subtract, so I'd have y to the negative 5 times y to the 2nd, and you add, so you get y to the negative 3, which equals 1 over y to the 3rd power. Power to a power is multiply, so I have 11 to the 6th over 11 to the 6th. Subtraction is 11 to the 0 power times 11 to the negative 4, which is adding, so that's 11 to the negative 4. And now it's negative, so your final answer is 1 over 11 to the 4th power. Next is I can apply properties of integer exponents. So it says how much greater is 2 to the 3rd to the 2nd power than 2 to the 3rd times 2 to the 2nd. Well, power to power is multiply, so 2 to the 6th minus 2 to the 3rd times 2 to the 2nd is 2 to the 5th. Okay, well 2 to the 6th is 64, 2 to the 5th is 32, 64 minus 32 is 32. What is the value? So 4 to the second is 15 to the 8th over 15 to the 8th, which means subtraction. So you have 15 to the 0. Anything to the 0 power is 1. Determine if the following is true or false. So this is multiply, so 8 to the 9th over 8 to the 4th. Well, 9 minus 4 is 5, so I have 8 to the 5th. This is adding, so I have 8 to the 9th over 8 to the 4th, which is 8 to the 5th. So this is true. All right, on the back of that page, it says I can apply properties of integer exponents, which is greater 4 to the negative 2 or 2 to the negative 4. How do you know? Well, 4 to the negative 2 is 1 over 4 squared, which is 1 over 16. 2 to the negative 4 is 1 over 2 to the 4th, which is also 1 over 16. So which is greater? You can either write neither or both equal 1 over 16. Number 17, find the value of x to make the following equation true. So this is subtraction, so you want n to the negative 2. So you need to think something times 1 gives me negative 2. So something times 1 equals negative 2. What would be times 1? So x has to equal negative 2. Because negative 2 times 1 gives me negative 2. 18, find the value of x to make the following equation true. So same kind of situation. So I have 3 to the 10th over 3 to the 11th, which is 3 to the negative 1. So I have 3 to the 6 times 3 to the something. So we need to think 6 plus what is going to give us negative 1. And the answer to that is negative 7. So x equals negative 7. I can evaluate square and cube roots. It says explain the difference between parenthesis to the second and no parenthesis. So negative 12 to the second would get us 144. And negative 12 to the second without parentheses would get us negative 144. Number 20 says evaluate. So 2 squared is 4 and 3 squared is 9. Number 21 says evaluate. Negative 5 cubed is negative 125. Says find both square roots of 196. Square root of 196 is 14 as a positive and negative 14 as the negative. Number 23 says evaluate the cube root of 64, which is 4. And number 24 says evaluate the cube root of 125 over 216. Well, the cube root of 125 is 5, and the cube root of 216 is 6. Number 25 says Willow purchases a vase for her kitchen that is shaped like a cube. That's key, shaped like a cube. And will hold 343 cubic inches of water. What are the dimensions, length, width, and height of the vase? So it's a cube, so that means all the sides have to be the same length. And the volume means basically you took that number and you cubed it. So we need to take the cube root of 343, which is 7. So the length is 7. The width is 7 and the height is 7. And we measured in inches. So everything is 7 inches. Okay, number 26. In the middle of a park, there is a fenced off area and the shape of a fence is a square. If the area of the fenced off portion is 225 square yards, what is the perimeter? A lot of you guys missed this part. You think it's just asking for the side length, but you actually need to find the perimeter. So since it's in square yards, we need to find the square root of 225, which is 15. And that's not our answer. Our answer is finding the perimeter. So you can either add 15 4 times or just take it times 4 because it is a square. So that would be 60 yards because we're measuring in yards. It says, I can estimate large and small values using powers of 10. So remember, estimate means we're going to round. So at number 27, rewrite the following value as a single digit times the power of 10. So I'm going to write it as I usually would for scientific notation. It's 8.29 times 10 to the what? 1, 2, 3, 4, 5, 6, 7. But because they want us to estimate, we're going to round. So we're rounding 8. 2 tells 8 to stay the same. So I'm going to have 8 times 10 to the 7th. Number 28, rewrite the following as a value as a single digit times the power of 10. So I'm going to have 6.8 times 10 to the negative 1, 2, 3, 4, 5, 6. I'm going to round 6. 8 tells 6 to go to a 7. So I'm going to have 7 times 10 to the negative 6. Last month, Levi had written 125 words of his book. This month, he is up 12,580 words. About how many times more words has he written this month than the first month? So how many times more means division. So we're still estimating here. So I'm going to take first the biggest number. So I'm going to have 1.258 times 10. 1, 2, 3, 4. Divided by 1.25 times 10. 1 to the second. Now, we're estimating though. So 2 tells 1 to stay in 1. And again, 2 tells 1 to stay in 1. So now I can divide. Well, 1 divided by 1 is 1. And when we divide, we subtract. So that's 10 to the second. Or in other words, 100. I can use scientific notation for large and small quantities. So number 30, a marine biologist discovered species with a diameter of 0.00085 inches. Express this measurement using scientific notation. So we're going to change this to scientific notation. So it'll be 8.5 times 10 to the negative 1, 2, 3, 4. Number 31, Frankie entered a sweepstakes to win a grand prize. Express this amount using scientific notation. So I'll have 1.05 times 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 10 to the 10th. Says, which of the following is the correct representation of that number? So I'll have 5 times 10 to the negative. So we already can tell that A won't be it because that's 50. D won't be it because it's 0.5. And C won't be it because it's a positive exponent. So B has to be our answer. 33, which of the following has a value that is greater than 10,000 but less than 100,000? So let's just write them out. So to the third, I would go 1, 2, 3. So that's 9860. Well, that's less than 10,000, so it can't be that one. I have 1, 6, and then 4 zeros. Well, that's way over 100,000, so it can't be that one. Then I've got this one with 3 zeros. That's less than 10,000, so it can't be that one. So it has to be D. I can perform operations with scientific notation. So 34, I first need to change this to scientific notation. So I'll have 8.45 times 10 to the 6 minus 1.2 times 10 to the 6th as well. Well, 8.45 minus 1.2, since they're the same base of 10, we can subtract those, and that gets you 7.25 times 10 to the 6th. Now we also need to write it in standard, so you have 725 with 4 zeros. Okay, number 35. I would change this to 3.3 times 10 to the negative 1, 2, 3, 4, 5 plus 5 times 10 to the negative 5. They both have the same base of 10, so I can add those, and I would get 8.3 times 10 to the negative 5. So then I would have 0.123483. After Becca's half marathon, her pedometer showed 23,580 steps, while Alex recorded 2.42 times 10 to the 4th steps after the same race. What is the combined amount? So combined means I'm going to add. So I need to do 2.358 times 10 to the 4th plus 2.42 times 10 to the 4th. We have the same base of 10. When I add those together, I get 4.778 times 10 to the 4th, which is 4778 and a 0. Okay, last three. Division. 7.2 divided by 4 is 1.8 times, when I have division, I subtract. Negative 3 minus negative 5 is 10 to the 2nd. So I would have 180. Number 38, I would have 5.28 times 10 to the 3rd times 3 times 10 to the 6th. 5.28 times 3 is 15.84 times 10 to the 9th, because you would add the 3 and the 6. Now remember, your notation has to be between 1 and 10, and this is past 1 and 10, so we're going to move it over by 1 more. So our answer would be 1.584 times 10 to the 10th power, which would be 1584 with 7 zeros. "39 from her campsite, Ava estimated that she could see 2,500 stars without a telescope. She read once a certain galaxy had 5 times 10 to the 11th stars. How many times more stars does the galaxy contain than what Ava estimates she can see?" So this is going to be division, because it says how many times more. So I'm going to take 5 times 10 to the 11th divided by 2.5 times 10 to the 3rd. 5 divided by 2.5 is 2. 11 minus 3 is 8. So 2 times 10 to the 8th. So I would have 8 zeros afterwards. And that's your study guide.